We've defined that we have microorganisms living with us, probably more than you want, or that you think you want. How do they get there? Now we can define this microbiome, we can kind of classify it. Our resident microbiome, our microbiota, these are bacteria that we gain very quickly in life, and they stay with us forever. They're found on all our surfaces, in our digestive tract, respiratory tract, anything that's open to the environment. This is considered our resident microbiota. This is not something that you wash away. Now, we can pick up transient microbiota. Typically, our pathogens are transient. We pick them up. So, say coronavirus is big right now. So, say you go out and you touch that virus and you get it onto your hands, and then you take it from your hands and you touch your mouth or your eyes, and it gets inside your body. That is transient. Now, your body's going to work hard to get rid of it. You either wash it away if it's on your hands before it can get in. That's the best situation. Or if it does get in, your immune system's going to kick in. It's not going to stay, and we're going to get rid of it. Those are considered transient microbiota. And so we're constantly picking up things as we move through our daily activities, but they may not stay. If they don't cause us any harm and our body doesn't fight them, they may become part of our resident microbiome as well. All right, so those are types of our organisms that we come into. And I do want to point out that when I'm talking about a person here and where our bacteria is living, I'm going to draw you a picture kind of on the side of this slide. And you know I can't draw well on the board. I can draw even less well in my computer. But this is going to be my representation of a person. I know it's pretty bad, right? But what I'm trying to convey here is an open tube. So, oops, I see I shouldn't do that. See, I'm working on it. So it's an open tube from that. So this is what I'm talking about when I'm talking about, yeah, see, I can't erase. I'll get better, guys. So this is what I'm talking about when I talk about carrying our microbiome. You can see in this picture here, our microbiome is going to be on the outside of our skin, and it's going to be in anything open to the environment. So if you think about your body in a big tube with the opening in the mouth all the way to the anus, this is where our bacteria is living. You can also think about smaller tubes coming in. Let's see if I can draw again. Ooh, I don't know. You can think about a smaller tube as like a respiratory opening here. You can think about that. You can think about reproductive organs. Being kind of a smaller opening in your tube. This is where our microbiome lives from that. Things that are open to the outside. You will not find them in your heart. You will not find them in your kidneys. Or liver, something that's not open to the outside. When bacteria get into those areas, that's where we have some problems, some diseases. As long as our resident microbiome stays where they're supposed to be, then we have that commensal relationship or mutualistic relationship. So do keep that in mind. This is nothing you need to memorize. It's just something that gives you some examples of bacteria. Oops, I'm still on pen. Bacteria and what that is about. See, I really should know how to erase. There I go. All right, so let's keep going. All right, so how do we get this normal microbiome? When you start gaining this as soon as birth occurs. Inside the womb, that is mostly free of bacteria. Now, we have found some exceptions. We'll talk about those, but it's mostly free of bacteria. But you know, have you heard of the phrase, their water's breaking? Someone's preparing to give birth and their water's broke. This is when the amniotic sac breaks. Now the baby is open to the environment. So it's in those canals where you can come in contact with bacteria. That's another reason why when they say your water is breaking, doctors will bring you into the hospital to monitor you. They'll probably go ahead and induce labor if labor hasn't started. If it's too early and they want to and they don't want to induce labor, they'll keep you closely monitored for any bacterial infection. The baby's just more susceptible to infections at that point. So that's what they're talking about. So as soon as those waters break, we are now open to contamination with bacteria, which is not a bad thing. Again, we have many of this bacteria that's going to become part of us, moving through the birth canal with others, breathing, eating, all of those things. The baby will start to gain bacteria from that moment on. So, do we need to still be careful about babies and wash hands if we're going to gain all this bacteria and we're learning more and more of that is a good thing? Do we still need to wash hands? I'm pretty sure with the state going on right now, you are very aware that washing your hands is necessary. We're not protecting against normal bacteria, we're protecting against pathogenic bacteria. We don't want that baby with an underdeveloped immune system to come in contact with that. So that's why you're limiting contact. But normal bacteria in the household, things that the baby's going to come in contact with, you don't need to be so germophobic that you don't want any bacteria, because gaining exposure to the different microorganisms we're finding is part of how our immune system develops, and it is important for that. Okay, so we've talked about the bacteria, we've talked about our microbiome, we've talked about where it's located, we've talked about how we get it. So let me tell you something, though, is that sometimes our normal microbiome that normally doesn't cause us a problem can end up causing us a disease. So there is a way that our normal microbiome can become an opportunistic pathogen. Again, pathogen, the ability to cause a disease, a microorganism that causes a disease. All right, so remember that slide I showed you right at the beginning, that picture of your bacteria that's in your nasal cavity? Many of us, about 60% of humans, carry Staphylococcus aureus in our nasal cavities. Not usually a problem. It's part of our normal microbiome. But if conditions are right and that Staphylococcus aureus gets into a different spot, moves past the nasal cavity, it can become an opportunistic pathogen. So if normal microbiota get in an area where they should not be, that is a way that our normal microbiome, our normal microorganisms can become a pathogen. An example of that is a urinary tract infection. UTI. We have E. coli in our gut. It's part of our normal microbiome. It serves a purpose there. If we get E. coli pushed up into the urethra, this can cause a urinary tract infection. Our normal E. coli that doesn't cause a problem in the gut can cause a urinary tract infection if it gets put into the urethra. That's why they tell you to be careful wiping. Don't wipe back to front because we don't want to push that. So anytime you get normal microbiota into an unusual site, this is going to cause a problem. All right, what else? When else can our normal microbiome become an opportunistic pathogen? If we are going through something else, disease, cancer, a transplant, malnutrition, our immune system may not work as it should. It becomes suppressed. Age can make a difference. Remember that little bitty baby? Immunosuppressed there. Are elderly. That's why we're so concerned about their exposure to the coronavirus that's going on right now. We are worried that their immune system may not be able to handle it, and there will become more damage in their bodies, and it can result in disease and in death. So this is why we're worried, this immunosuppression. So if you are at risk because of one of these things that your immune system is not doing well, some microbiota, some microorganisms that won't bother other people or that you already had with you can become a pathogen. AIDS patients, that's one of the ways we diagnose AIDS, is that an AIDS is caused by a virus, HIV. That virus gets into your body and attacks your immune system. It attacks your T cells and you have no defenses. And eventually it attacks enough T cells that you come across a pathogen that most of us could doesn't even cause a problem, and it causes a disease in these AIDS patients. So that is another way that your normal microbiome can become an opportunistic pathogen. What else? Changes in your normal microbiome. Say you are taking a antibiotic. You've got maybe that urinary tract infection. Your doctor prescribes a broad spectrum antibiotic. It's going to get rid of the bacteria causing your urinary tract infection. It's also going to kill a good percentage of your normal bacteria that we say doesn't hurt us and in some ways helps us, and we're finding out helps us more and more. This can cause a change in the percentage of bacteria that you're carrying around. And your bacteria, your microorganisms, are taking up space and taking up nutrients, and just their presence can prevent a pathogen from getting inside and taking and gaining nutrients. So an example of that is we all carry a little bit of yeast in our system. It colonizes the female vaginal region as well, colonizes that. So you get a urinary tract infection, you get rid of the bacteria. The yeast is not gotten rid of by that antibiotic, and the antimicrobial only affects the bacteria. So the little bit of yeast that we normally carry suddenly finds all of its competitors gone, and it will start to replicate and be able to gain larger than normal numbers. So then your urinary tract infection gets solved by your broad spectrum antibiotic, but now you end up with a secondary yeast infection. This is when that normal yeast that you carry now is overgrowing because the normal bacteria is not there to kind of keep it in its place. Okay, so changes in your normal microbiome can cause an opportunistic pathogen, or normal microbiota become an opportunistic pathogen. This process, this is called microbial antagonism. It's where our good bacteria are taking up space and keeping pathogens from coming out.